Welcome to a terrific, wild Wednesday, everybody. We are taking up this quiz. We're starting on page 2. I'll go back and make a video for page 1 again later. So we have exponential equations that we want to be able to solve here. And these require writing these bases as a common base. Just like when you're adding fractions, you like common bases so that you are common denominators so that you can do the operation. Same thing with exponential equations like these ones. When we have common bases, we can set the exponents equal to one another. So that's what we need to create here. 5 to the 3x plus 2. X is an unknown. There's one unknown in this equation, so I can't solve for it. This is equal to 125. Well, I can write 125 as 5 to the 3. Prove it to yourself. 5 times 5 is 25. 25 times 5 is 25 times 4 plus 1. 25 times 4 is 100. 25 times 1 is 25. 100 plus 25 is 125. There it is. So that's how I do 5 to the 3 in my head. I know, it's just easier ways. Okay, so now we can say 3x plus 2 is equal to 3. Okay, these exponents must be equal to one another because they have a common base now. So that's just something we can solve. 3x equals 1 because I subtract 2 from both sides. And then I divide both sides by 3 to get x is equal to 1/3. Check it in your initial equation up here. 3 times 1/3 is 1. 1 plus 2 is 3. 5 to the 3 is indeed 125. I've already talked about that. Not going to talk about it a second time. Here, I have to go by way of the number 3 to create a common base. So, because 27 is not a power of 9, unless you consider that 9 to the 3 halves is 27, which I know some of you could do, and you could solve this question that way by writing 27 as a power of 9, and it's 9 to the 3 halves. But if you can't do that, no problem. Go to the common base of 3. So 27 could be written as 3 to the 3. And then I put that in brackets, and I raise it to the power y minus 1 because instructions here. And that's equal to 9 is 3 to the 2. And then I'm going to raise that to 2y to the negative 4. Notice that what I've written down here is exactly the same thing as what's written there. It's not different by a single thousandth of a point. It's exactly the same thing. I just wrote 27 in a new way and 9 in a new way. So now we can keep going here, and we will get, we just use our power of a power rule. So I multiply this by this. So I get 3 to the 3y minus 3 because distributive property, okay, is equal to 3 to the 4y minus 6. Minus 8. Yeah, 8. I'm feeling like these are just different versions of themselves, and y is just going to be of the real numbers. Okay, so now I know that 3y minus 3 is equal to 4y. Oh, no, it's not. Minus 8. Okay. Minus 8. What the heck? Okay, so now I'm going to isolate my variable. And I see I could move all the y's over here. I could subtract 4y from both sides to get negative y over here. Or I could subtract 3y from both sides and get positive y over here. That sounds easier. So let's do our inverse operations this way. Let's move the y's to this side by going minus 3y from both sides. And I like writing this right underneath the term where I'm going to be collecting my common terms and then adding 8 to both sides. Okay? And that will give me my answer right away of, negative 3 plus 8 is 5 is equal to 4y minus 3y is y. Boom. And then you can go back and check your answer up here. So 5 minus, 5 is equal to y. So let's check it up here. Okay. 5 minus 1 is 4. 27 to the 4 we're suggesting is equal to 9 multiplied by, this would be 9 to the 6. So is 27 to the 4 the same thing as 9 to the 6? And you would check that on your calculator and find that it's true. I don't need to do it on my calculator because I've already done the 2/3 thing in my head. Okay, well, let's carry on. That's your final answer right there. I gave you lots of space for that one. In the year 2000. Does anyone watch Flight of the Conchords? Anyone know Flight of the Conchords? Oh my goodness. A comedic duo from New Zealand. I can recommend them because they're not R rated. And yeah, it's very, very funny. They have a song called In the Year 2000. But they're singing it, but they wrote the song before the year 2000 and then they're singing it after the year 2000. It's very funny. Okay, the population of Ontario was blah, 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 blah. No one cares, Mr. Jennings. All right, here we go. So predict the population. So the first thing I need to do is to create a function. Population is a function of time. If some people said amount is a function of time, no problem. You can use whatever letter you want. You could even use a Greek letter if you want, but I'm going to use letter P, okay, because it's population. Is equal to the initial value, 10,100,000, multiplied by the growth factor, which is 1, plus this written as a decimal, 0.011, raised to the power t. This is my equation. And I have been asked to predict the population in the year 2020. 2020 is 15 years after that, and that's my year 0. So this will be year 2020 minus 2005, and that would be year 15. So let's find P at 15 is equal to 10,100,000 multiplied by 1.011 raised to the power 15. And then you do that and you find that your answer is, drum roll please, who's got it? Someone save me getting a calculator out.
11,901,143.
901,000?
Yeah.
144. 144. Yeah, someone's having a rough day. That's me today. Ha ha ha. Okay, so this is our answer. Everyone gets. Other people get that answer, so we can trust it. Great. Yeah. Yeah. Super. So that's what it's going to be. Then you evaluate your answer. Okay. And you can evaluate it by checking in Desmos or something like that. But you also look at these numbers, and you say, did a 1% growth rate per year sound reasonable? And if it does, and indeed that's about how populations grow, then you would say, would it then seem reasonable that it would grow by about 2 million people, nearly 2 million people over 15 years? And you would say, sounds about right. I didn't get a number here like 80 million, or I didn't get a number here like 10, so those are, this should feel like a good number that matches your intuition for how these numbers sort of work. Okay, so you always want to check this based on your understanding. Now we've been asked to estimate the year in which the population will be that. We have a big clue here. It's going to be a little less than 15, isn't it? So, I've talked about guess and check on the board. What you can do here is, what am I doing there? Is you can go to Desmos and look at it and find a very close answer, or you can use logarithms and find the exact answer if you're working ahead. So what you would do here is you would create your chart T, and you know that 15 is already a really good guess, but it's a little too high. So you might guess 14. And then you would evaluate this function here, but instead of a 15, you would have a 14. Or you could just take your answer and divide by 1.011. And that would effectively lower the power of this by 1 because you're dividing by it one time. And you're applying your exponent laws in your head, and you're saying, I've already got that number on my calculator. Let me be a little advanced with how I do this. You can do that, no problem. Or you can graph it in Desmos. Let's do that. I love graphing things in Desmos. So let's go and get a Desmos. And then we go here and we say y is equal to 10,100,000 multiplied by 1.011 raised to the power of x. And then you say, Mr. Desmos, please show me numbers that go up to about 20 years. See how this helps you? Like you're thinking about what these numbers mean. So you're like, okay, I'm going to also show numbers that go up to maybe about 15 million. I want to see the whole curve there. There it is. Okay, and then we put this away. Click over here, put that away. Put me away. Okay. And then here's 20 years, and the population's going to be up there at, these are scientific notation. Can I get the scientific notation to go away? No, I can't. I don't think I can. No, whatever. Okay. This is 10 million. Okay. This is 1.5 times 10 million. So this is 15 million up here. All right. Now, I would graph the line y is equal to the desired answer, which is 11,140,000. 11,140,000. And there, this is our answer right here. 7 years. Okay. So this is 8.9. This is in 9 years. Is that the answer that people get? Yeah, about 9. Okay, I'm a little surprised, but all right, there you go. Sorry.
Logarithmic function says it's 8.959.
Yeah, sure, great. 8.959. So this is basically 9 years. In the 8th year, right before the end of the 8th year, the population will go up. So if you gave me 9 years, or if you gave me in the 8th year, I would accept both answers. So here, 14 gives us a number that's too big. When we keep guessing, maybe we guess down here 9, and we get very, very close, and we are satisfied. Yay! And so we say, in the year, and what was our first year? 2005. So 2005 plus 9 is in the year 20. This is a 2. 2014, the population. Where?
It's a T.
That's a T. T for time. Yeah. In the year 2014, the population will be this. Okay. Next, we talk about half-life. So polonium 2010, polonium 210, is a radioactive substance with a half-life of 21 weeks. This is interesting, as a Fibonacci half-life. So how much of a 400-gram sample would remain after 52 weeks? Well, it's not just after 42 weeks, which would be 2 half-lives, there would be 100 grams left. So I'm expecting an answer a little bit south of 100. How do I know that there'd be 100 left? If there was 42 weeks, that would be exactly 2 half-lives. Exactly 2 half-lives would be a half times a half is a quarter. A quarter of 400 would be 100. So I already have a very close estimate of what I'm looking for. This is going to be around 90, maybe 80, somewhere in there. So the way I set these up, and having that estimate helps you check your answer when you get there. So you want to do that. You want to take a step and absorb the question. The amount left over is a function of time, and it's going to be equal to the initial value, 400, multiplied by 1/2. You can use 0.5 here if you're a mutant and you prefer decimals still. And that's raised to the power t, divided by the half-life, 21 weeks. That way, when I put 21 here, I will get 1, and that will give me half of this. That's by definition kind of what I want. Now, I've been asked to find how much will be left at A at 52. And this is just a plug and chug now. 400 to the 1 over 2 multiplied, raised to the power 52 over 21. And these don't share any factors. There's no way to reduce that fraction. You don't need to reduce that fraction. Just punch it on your calculator. And when you punch this on your calculator, you get the answer of...
71.89.
Sorry?
71.89.
71.89. So how was my guess? I said around 80 or 90. And the answer is 71.89. How's my guess? Yeah. Do I think this answer is wrong? No. I just update my guess a little bit. This is definitely in the right range of numbers. I did not get an answer like 1,000,000, and I did not get an answer like 0.25. Like I got an answer that's pretty close. It's within 80% of my guess. So that's really close as far as exponentials go. Okay. So that's how we do those types of questions. Oh, and you'll want a therefore statement on stuff like this. Sorry. Therefore, there will be 71.89 grams of polonium left after 52 weeks. Write each expression in radical form. Okay, so when I write these in radical form, I say this is equal to the second root. This number here comes in there. The second root of x raised to the power 5. Another answer I would accept is the second root of x brackets raised to the power 5. I prefer this. This is nicer to me. It's easier to understand. Okay, k to the 4 over 5. This is equal to the fifth root of k raised to the power 4. Just definitions. Okay, memorize these definitions. Write these expressions as a rational exponent. So now we're going in the other direction. Okay, so this is equal to n to the 5 over 4. Just like before, this number comes down here. This number goes up there. This is x, the third root of x. This is equal to x to the 1/3. Okay? Okay, let's keep going. Simplify each. Okay, 8 to the 2/3. So I think of this as 8 to the 1/3 raised to the power 2, because this multiplied by that gives me that. So I break it up that way, and then I know that 8 to the 1/3, that's the same thing as the third root of 2. But I'm not going to write that. So third root of 8, which is 2. So that is 2 raised to the power 2, which is equal to 4. Yeah. Okay. And then to make my work more beautiful, I'm going to strive for more vertical equal signs here. 64 n to the 4 to the 3 over 2. Okay, so to do one like this, I raise everything that's in here to the power 3 over 2. I'm going to do that first. So this is 64 to the 3 over 2, and that's going to be, oh man, that's a big number. N to the 4 times 3 over 2. So that's n to the 12 over 2, which is n to the 6. Maybe I should write 12 over 2. This is n to the 12 over 2, because 3 over 2 multiplied by 4 is 12 over 2, which reduces to n to the 6. Okay, so 64 to the 3 halves is going to be smaller than 64 squared, but it's still going to be quite big. It's yeah, it's 14. Sorry, it's a 16 cubed. No, it's 4. No, it's 8 cubed. 8 cubed. Yeah. So then I could rewrite this as 64 to the 1/2 raised to the power 3, and then n to the 6. 64 to the 1/2 is 8. So that's 8 to the 3, n to the 6, and then this is equal to, hold on one moment. All right, so let's keep going. So, and then 8 to the 3 is 64 times 8, which is, Siraj, what is it? 512? Yeah, 512. Sounds very correct. 512 and to the 6. I need to develop my powers better. I should know that. Okay, because that's just a power of 2. All right, so yeah, so drink that in for a little bit. Yeah. Okay, and then 16 to the negative 3 over 4. All right, I'll start that one. I'll do it in a different color so it stands out a little bit better from the work that's up there. This is equal to, well, I don't like negative exponents, so let's put that on the bottom. 1 over 16 raised to the power 3 over 4. Okay, which is equal to 1 over 16 to the 1/4 raised to the power 3. 16 to the 1/4. 16 to the 1/4 is 2. Find me some number that when multiplied by itself 4 times gives me 16. That number is 2. So this is 1 over 2 to the power 3. This is 1 over 8. It's 1 over 8. Okay, so that's what we did today. Okay, so now you can go through, find the marks for your friend. Find the marks for your friend.
Wait, what was the answer for the last one?
Oh, 1/8. 1 over 16 to the 1/4 is like saying I have a number 1 over 16, and it was the product of x to the 4. Find me x. So that would be 1 over 16 equals 1 over 2 to the 4. So their x is 1 over 2. So this here was 2. This is 1/2 in here to the 3 is 1 over 8. Okay. Oh, and while you're totaling up the marks, I'll go through and talk about the first page. So I'll go back up to the first page and talk about it now. That way it's not a second video. Oh, okay. So, and then when you're done, you can total up the marks here. Knowledge and understanding should total to 27. Application totals to 3. I'll do the communication mark when I go through people's work to see, how tidily they lay things out and stuff. I probably give myself a 3 for communication. I feel like I kind of ugly here. Actually, I probably wouldn't. I'd probably give you a 4 for this. So anyway, these types of questions, you add the exponents together. This is x to the 5 because it's x to the 2 plus 3. So that's a product of a power rule. Quotient of a power rule, when you're dividing powers, you subtract the bottom one from the top one. So this is y to the 4 minus 7 is y to the minus 3 is 1 over y to the 3. This one, b to the 3 to the 4, there we multiply the powers. So that's b to the 12. 6 to the 0 is just 1 because anything to the 0 is 1 so long as that anything is not 0. Okay, so yeah. If you have a non-zero base and you raise that base to the power 0, the answer is 1, always. Simplify the following exponential expression. Do these exponents first. You want to do exponents first and then your brackets and then your multiplication, okay? So you have to do these powers of a power first. So I did that. This negative one I threw to the bottom here. You see 3ab to the negative 2 became 3 squared, a squared, b squared. But because this was a negative, I put it to the bottom. This negative brought this chunk to the top. So I had a to the 3 on top. B to the negative 2 times negative 3 was b to the positive 6 on the bottom. And when it came up, it became b to the negative 6. Okay? You could have left it on the bottom, but that would have been confusing. It's already confusing. Now we do product of powers rule. A to the 3 times a to the 3 is a to the 6. B to the 6 times b to the negative 6 is b to the 0. It means 1. It means we don't write it down anymore. That's a to the 6 multiplied by 1. And then on the bottom, 3 squared is 9. A squared, b squared is just a squared, b squared. There's one last thing to do, which was to resolve this into a single power of a, which was a to the 6 minus 2, because we have the divide by a power rule, so we have a to the 4 over 9b squared. And that was the first page. In that case, takes us up to the second page, and that was our morning, everyone. I hope that you all found that fruitful, and email me any of your questions.